Okay, so our topic is 5G use cases, no, or eMBB. So when we say eMBB, it's the enhanced mobile broadband. Although I prepared some topics here, but I think it's not enough. We don't have enough time to tackle all of this. So what is 5G, the 5G promises, the use cases and families of 5G, which is eMBB, URLLC, MMTC, and the 3GPP position with 5G, the services and requirements for vertical sector. But I want to focus deeply on the 5G user throughput calculation. Okay, this is something more uh, technical, no? When you talk about the different topics that I prepared for you. So we could have a glimpse of these topics, and then we'll focus more on the 5G user throughput calculation so that you'll have some idea how is the theoretical calculation, and then how can we relate it into practical applications. Is that okay with you? Okay, so let's start with the 5G concept muna. No? So what is 5G? So as mentioned already by um, Engineer JM, so 5G is the fifth generation of wireless technology. And it's faster than the existing mobile connectivity, lower latency, energy consumption, and greater capacity. And meron tayong tatlong use cases, which are enhanced mobile broadband, meaning higher data throughput and higher capacity, massive machine type communications, meaning massive internet or the Internet of Things, and ultra reliable and low latency communications. These are um, low latency communication systems up to 1 millisecond, and reliability of 99.999%. Okay, so that is basically 5G. And if you look at the 5G application and solutioning, so if this is your current existing or existing setup of a 5G, usually you will see antennas, legacy antennas. So you have the 900 antennas, 1800 or 2100, and in some cases, you will see a multi-band antenna setup where all the legacy technologies are combined into a single antenna. So we call it multi-band antennas, which range from 10-port to 12-port antennas. Okay. Now, if you want to deploy 5G, particularly in the 3.5 gigahertz, you need to have another set of antennas like what you can see on the screen. This what they call currently is a 5G active antenna unit. This is an integrated antenna and with the integrated radio on it. It's a massive MIMO antenna solution. Okay. So the current setup is you have this massive MIMO antennas or the 5G AAU connected to the new BBU, which what we call the EC3. Okay, and then there is also GPS for synchronization. You will see the GPS antenna, especially for those TDD, the time division duplex applications or mode of 5G. Of course, synchronization and timing. Okay, so that is the 5G. And if we look at the 5G use case families, as mentioned, we have three fundamental use cases: the enhanced mobile broadband or the eMBB, which is giving us high capacity and high throughput. Massive machine type communications. These are massive IoT. You can see the applications in the smart city, smart home, and smart buildings. And then we also have the ultra reliable and low latency communications or the URLLC, which is applicable for critical application or mission critical applications like e-health, remote surgery, and self-driving cars, which yung latency is very important. Okay? Yung response, instant response ng ating network. Okay? So, when we look at the different use cases, going, for example, sa ultra reliable and low latency communication. So these are the different applications that you will see. So high reliability and low latency, higher reliability and higher availability and lower latency, higher accuracy in positioning, very low latency like the tactile internet, higher availability and mission critical services. So URLLC is defined as the network for mission critical and real-time low latency applications that require uninterrupted and reliable data exchange. So some of the applications are remote surgery, immersive gaming, remote manufacturing, traffic safety and control, um, a remote training, and autonomous car. Okay. So URLLC is targeting a niche market, no, specialized market, especially sa mga automobile or yung mga remote surgery or health applications, no. Yan. And it has ultra low latency, up to 1 millisecond in latency, high resilient communications, and with redundancy, and reliable device-to-device communication. We call it the side link. No? So this is the URLLC. And then the second use case is the MMTC, or the Massive Machine Type Communications. This is also called the Massive IoT, or Internet of Things, that refers to the enormous. No? When you say enormous, it's a big word, no? Enormous. Number of IoT sensors and devices. And that will be communicating with each other. So actually, this is an evolution of the IoT technologies we have today in the 4G. If you're familiar with this narrowband IoT and LTE-M, so this is an evolution of that one. So we upgraded from the narrowband IoT to LTE-M. And in the next session, probably for 5G, on a deeper discussion, you will hear the term RedCap, no? RedCap 5G. That means reduced capability of 5G. It's similar with the narrowband IoT and LTE-M. So these are applicable to smart cities, logistics like smart ports, okay, warehousing, tracking, smart industries, smart agriculture, and fleet management. And MMTC is efficient and low cost communications with deep coverage. So these are applicable for deep indoor coverage applications, high density, up to 1 million devices per square kilometer. And the battery life is 10 years, no? The battery life before you replace it. And I will focus more on the enhanced mobile broadband because during the first launch or deployment of 5G, specifically here in the Philippines, eMBB is the one that we experience, no, deeply. Ito yung nakita natin agad, no, yung eMBB, the enhanced mobile broadband. What is eMBB, no? eMBB is the natural, no? The term is really natural evolution to existing 4G networks. And that will provide a better user experience than current mobile broadband services. So, ang mga gamit niyan is, seamless connectivity, high data rate scenarios, okay? So that will compete with the fixed broadband services. Actually, panlaban nila to sa sa mga fiber optic connections. Because there's a challenge, right, when you are deploying fiber optic or fiber to the home. If there is, for example, merong regulatory restrictions, ayaw papasukin sa community, ayaw papasukin sa subdivision, so they having a hard time, no, penetrating yung mga subdivisions na yan, so they can still connect the houses and establishment using 5G with a fiber-like connectivity. That's why what is being said here, that it will compete with the fixed broadband services. And then high density scenarios, okay, higher user mobility, fixed mobile convergence, and femtocell deployments. Okay. So that in theory and in the target of 5G, they are targeting up to 20 gigabit per second in downlink. But it's important to note that the 20 gigabit per second is still on the target side. So me personally, I haven't seen any 20 gigabit per second right now. No, it's the same with the LTE in the previous years. Dati when LTE was deployed, the target throughput for LTE was 1 gigabit per second. Okay, but in the initial deployment, we have 150 Mbps, and then we saw 300 Mbps, up to 400 Mbps, 500 Mbps, and then just recently, some organization or some companies reach the 1 gigabit per second, which is what they call the gigabit LTE. Okay. So the target is just like the the holy grail of your objective. So it's not meet on the first day of the deployment of the technology. Okay, that's what I'm trying to say. Because when we're trying to um, to show it, especially for critics, no, 20 gigabit per second, it's impossible. No, so we need to give time to the technology because 5G is not a standalone technology. Remember, 5G is a culmination of different technologies, massive MIMO, higher order modulation, and then you will see later on what are the compositions of this technology to achieve a certain throughput like 20 gigabit per second. Okay. Okay, so if you have a higher throughput and higher capacity, of course, you will have a mobile FWA, virtual reality, augmented reality, smartphones, and even 4K, 8K, or ultra high definitions experience. Okay. All right. So um in the Philippines, during the pandemic era, no, so this is where the 5G deployment started. So and then we have the opportunity to get one of the testings in the 5G, and then this is particularly from Smart Network. No? So this is a sample 5G test in Clark, and you will see that in this mobile, they have achieved 1,000 plus Mbps. So that is equivalent more or less 1 gigabit per second. Okay, so our current network right now here in the Philippines can achieve 1 gigabit per second. So this is also the same with Globe and Dito. I didn't have any screenshot of their testing, but I saw some publications that they already met the 1 gigabit per second. Okay. So in the Philippines, it's a good news we can achieve this kind of throughput in terms of the eMBB or the enhanced mobile broadband. Now, what is happening? No? In this session, we will talk about how can we calculate or how can we estimate the throughput of an eMBB from 5G. Okay. So like this, how did we achieve this 1 gigabit per second? Okay, so if you use a drive test tool, like for example, a Pilot Pioneer. So this is what you see in your mobile phone as a user, but in the back end or at the back end, you will see this kind of different parameters. Okay, so there's a lot of things happening, no? Sa background ng ginagawa ng, for example, a simple speed test like this. This one is a simple speed test getting around 518 Mbps in the download and around 40 something in the upload. So you will see that there is a hindi pantay, no? I forgot the English term. Hindi pantay yung upload and download niya, no? So it is based on the settings on the network. Okay, it always depends on the settings of the network. Now there's a question earlier that if you're connected with an NSA network, sino yung nagbibigay sa iyo ng throughput? Is it 5G or LTE? Now let's look at the drive test tool. No, you will see here in the drive test tool so that the first timers can also familiarize themselves. No? So you will see the parameters here. So these are the parameters of the 5G. Okay, so you can see here ENDC, the EU TRAN NR dual connectivity. When we say ENDC, there's a 5G component and there's an LTE component. Okay. And then if you see a 5G signal in your phone, most likely that your phone is connected to 5G and LTE simultaneously. How can we prove that? No. You will see here the parameter for LTE. So now this phone is being served by or a band 1 LTE, which is 2100 megahertz. And at the same time, there is a band 78. Band 78 is 3.5 gigahertz. So you have L21 and NR 3.5 gigahertz. So you are connected to LTE and 5G at the same time. Now, if you look at the throughput, you will see here the parameters in the download in Mbps. and upload in Mbps, you will see that there is a throughput that is coming from 5G, and there is also a throughput that is coming from LTE. No? Later on, kapag gana siya. Okay, so that means the throughput that you're getting from the network is coming from 5G and coming from LTE. That's why it's called also eMBC. Okay, and the other parameters will probably will discuss it on other sessions. But for the meantime, that is the message that I would like to share with you. Okay, so eMBB. So how do we calculate the UE throughput of a 5G? How do we estimate it? So what are the different factors to consider? For example, if you're asked in the interview, what would be the theoretical throughput that you can achieve using a 5G system with this frequency, with this bandwidth, with this modulation, and with this MIMO setup? So in this session, you will learn that. Okay? So are you ready? Before we start, can I get a thumbs up? If you're ready. Because we have limited, I already have 1 hour. Okay. Okay. So now let's talk about the 5G user throughput calculation. So user throughput calculation meaning this is the throughput that is being achieved by your user equipment. Okay, it's not the cell throughput level because it's a different thing. It's cell level throughput and the user throughput. Okay, so it goes with a simple formula coming from 3GPP technical specifications 38.306. So I apologize for being too technical, no? So this is the formula. This is the formula that we need to understand, okay, in this session. So the data rate in Mbps is equal to the 10 to the negative 6 multiplied by the summation of all the layers, okay, all the layers, all the supported modulation, the scaling factor, multiplication of the maximum coding rate, multiplied by the number of physical resource blocks, multiplied by the number of subcarriers, divided by the numerology, multiplied by the overhead used in the network setup. So this is it, no? So this is under the 3GPP technical specification 38.306. Now, if you want to know what is that technical specification, you can go to the 3GPP and go to the specification standards, and then hold on. Yeah, so this is the specification. So if you're bored at night and then you want to fall asleep, it's a good way, no, to mingle with this kind of ideas and theories. Hold on, I'll just having hard time on the. It's not responding. It's not responding. Later on, I'll show it to you. I'll show it to you. Ayan. Ayan, ito. So this is the technical specification. So you can download the latest one, no? So that is March 2024. So take note of this technical specification 38.306. So for those people who would like to dig more about the specifications of the 3GPP, this is the user equipment radio access capabilities under the release 18. Release 18 is what we so-called the 5G advanced. Okay. So if you cannot fall asleep at night, so you can read this. No? Yeah. So this is where the formula came in. No? Yeah. Yeah, ito yung formula natin. Okay? So in today's session, this is the one that we will be discussing. Okay, for the eMBB. Okay. So going back to our discussion, let me just okay, so these are technical specifications. So this is the source of the information. So I simplified it further into this slide. So the 5G NR throughput, for example, for the UE. So first we need to have the mode of 5G network. So what is the mode of 5G network that affects the throughput of your system? So we have major two types of 5G mode. So our 5G could operate in a TDD or an FDD mode. Okay, so what's the difference of FDD and TDD? I think there's a question earlier. What is the difference of TDD and FDD? And for most of you, I believe you already know this. So FDD means frequency division duplex. So you have your mobile phone, you have your G node B or cell site, and then you have two types of transmission, the uplink transmission and the downlink transmission. So the uplink transmission is the one coming from your mobile going to the cell site. So we call it the uplink. It's the same concept with the satellite communications. So you have the uplink signal and the downlink signal. Anything that you transmit from your mobile phone going to your cell site, we call it the uplink. And the signal going from the cell site going down to your UE, we call it the downlink. If this transmission is happening using different frequencies for uplink, different frequency for downlink, we call it the FDD, the frequency division duplex. Okay. Now, if you're using a TDD or time division duplex, your mobile phone and your G node B are communicating with each other using uplink and downlink, but they are using only one channel or frequency. In this case, you're only using one set of frequency. So we call this setup or mode as TDD. So the separation of the uplink and the downlink, meaning the time duration, is not perceivable by the human ear. No? So we cannot identify if it's changing from uplink and downlink. Okay, so these are the two modes of operation. And if you look at the different frequencies in the Philippines, so we have different types of frequencies in the Philippines. We have 450, 700, 850, 900, 1800, 1900, 2000, 21, 23, 25, 33, 35, and there are upcoming frequencies in the millimeter wave frequencies. We're just waiting for the frequency allocation from NTC kung kanina nila i-award yan. But in the meantime, ito yung ating mga frequencies, no? So the orange one are the frequency division duplex, and the blue ones are the TDD or the time division duplex. So if you see yung mga frequencies na yan, so 700 is FDD. So meron ka separate frequency for uplink and separate frequency for the downlink. Okay. Now, if you want to go into more detailed frequency allocation, so this is the frequency allocation. That is a 3GPP release 16. No? But it's the same thing, but meron lang konting kadagdag na mga frequencies. So you will see the different start-stop frequencies from the uplink and the downlink and the TDD mode. Okay. Now you will see here supplementary uplink and then supplementary downlink. So these are for specific purposes that you want to add additional downlink frequency to support yung mga link budget and additional capacity needed, no, for your setup. But the two main modes are TDD and FDD. Okay. So sa Pilipinas, these are the most famous frequencies also in different parts of the world. Okay. So we understand now the mode of 5G network. Okay? Did everybody get it? Okay ba to? Clear ba yung 5G network mode? Okay. Why 5G use TDD? Because it depends on the frequency. Emir, if the NTC gives you a frequency in the millimeter wave, the ITU has set a standard that the millimeter waves are working in a TDD. So we are encapsulated by the International Telecommunications Union. So that is being agreed, no, worldwide. Okay. Next is the number of aggregated carriers. How many carriers are we utilizing in 5G? Aggregated, meaning we are using carrier aggregation here. Okay, actually, this is a more advanced feature of 5G because in the current setup that we have, we don't use carrier aggregation yet in 5G. We only use one carrier for 100 megahertz. But in the 3GPP specification, they mentioned that it is possible for 5G to have a carrier aggregation. That's why in our calculation, you will see that there are summation of all carriers here. So meaning in one carrier, you can in one connection, you can have multiple 5G carriers that is serving your UE. Okay, so what is carrier aggregation? No? So carrier aggregation is something like this. No? So we have different types of carrier aggregation. So we have what we call the intraband aggregation or the contiguous component carriers. So meaning if you have carrier 1 and carrier 2, you can sum it up. Okay, parang ano yan, parang gripo. Binuksan mo yung isa, binuksan mo yung isa, sabay mo binuksan and then you will get plenty of water. Mabilis mapupuno yung yung balde mo. So that is carrier aggregation. Contiguous. The intraband aggregation can also be non-contiguous. So meaning you have channel 1 and then channel 10, you can also combine these two carriers. Okay, so that you can also have a greater throughput capacity. And then we also have the interband aggregation. Interband meaning you have 2100 and on the other side you have 1800. So you can also combine these two carriers. So we call it the interband carrier aggregation. Now in the case of LTE, in the release 10 up to 5 component carriers. And in the release 11, release 12, and 13 up to 32 components. Okay? So this is what we call the carrier aggregation. Okay. Carrier aggregation is clear? Can I get thumbs up? Medyo marami to. Okay. I want to isa-isahin natin yung mga components so that we can understand. Okay? We can understand the formula before we go to the final formula. Okay, next is the number of MIMO layers. So this one is already explained by Engineer JM earlier, no? MIMO layers. Ilang layers of MIMO are we using? Okay? So we have different types of MIMO, right? So we have 4x4 MIMO, we have 4x2 MIMO, 8x8 MIMO, or 2x4 MIMO. So in some advanced networks, they use 8x8 MIMO. So meaning, if we use certain type of MIMO, like for example, 2x2 MIMO, essentially, to make it simpler, essentially, we have times 2 of the data throughput that we get because you are transmitting different streams of information multiplied by 2. If you have 4x4 MIMO, it's 4. 8, you can theoretically get 8 multiplicator, no? Or multiplier. Hindi pala multiplicator. Okay? So that is number of MIMO layers. Next is, of course, the bandwidth. Okay? Bandwidth. Gaano kalapad yung frequency? Okay? So we all know that the spectrum is the key asset for mobile operators, right? And we have different set of frequencies. We have the low band, we have the mid band, and then we have the high band. And each set of frequency has their pros and cons. For example, in the low band, it's very good for covering greater coverage than the high band because of this the properties of the electromagnetic waves, no? So the spectrum is the key asset, no? So it defines how much capacity and it defines how wide the coverage is, no? So mas malapad yung bandwidth mo, so the more vehicles can come in. So that's the analogy for that one. So mas malaki yung yung bandwidth mo, so mas maraming kotse, mas maraming bus ang makakadaan. Essentially, mas maraming traffic ang pwedeng gumamit ng frequency. So that is what's so called the bandwidth, no? And then if you look at, no, yung mga bandwidth dito, no, sa higher frequency, for example, in the NR band 257, this is starting from 26 gigahertz up to 29 gigahertz. So essentially, this is around 3 gigahertz, 3,000 megahertz ang bandwidth dito. Pakalaki, no? 3,000 megahertz ang bandwidth niyan. And if you go for the 3GPP, you can go up to 400 megahertz na bandwidth, no? Now, if you compare it sa bandwidth naman ng, for example, 2100, so you only have around 60 megahertz kung ma-allocate lahat sa'yo. But here in the Philippines, it's not happening. Okay, probably the maximum bandwidth that we can get for 2100 is around 25 megahertz. We did not even reach the 50 megahertz line. Okay, but in the 3.5, in the 3.5, you can see here, meron tayong sufficient capacity or bandwidth because, for example, in the 3.3 to 3.8, you have around 500 megahertz. So one operator or two operators got around 100 megahertz of allocation. No? So yung isa naman, 60 megahertz lang. No? Pero malaki pa rin yan. So you will see how important itong bandwidth na to. No? Bakit importante ang bandwidth no? sa 5G? Because it defines yung number of resource blocks na pwede nating i-transmit sa network. So the number of resource block meaning dito mo nilalagay yung number of bits of information, no? Para ma-transmit mo yan. Parang kalsada nga, di ba? So the kalsada is the bandwidth that you have. And then the number of vehicles that carry your number of bits, these are the user plane, no? Na nagpapadala ng mga information mo. Okay, so if you look at the channel bandwidth, so this is how it is being dissected. Okay, so you have the channel bandwidth, the transmission bandwidth, okay, and then you will see the resource blocks. Now, the number of resource blocks is depending on the sub-carrier spacing that you are using. Mamaya pag-usapan natin yan. We call it the numerology, the 5G numerology. Okay, so every numerology has a different assignment for each bandwidth. And you will see here the maximum bandwidth that we can allocate based on the 3GPP standard is 400 megahertz. If you're using the FR2, which is very logical. Because if you assign 400 megahertz in the FR1, there is no 400 megahertz na bandwidth pa sa FR1. Like for example, the 2100 megahertz, the maximum bandwidth we only have is 25 megahertz or 60 megahertz. Yun yung maximum bandwidth nun. So why you are allocating 400 megahertz, right? So that's why the 400 megahertz bandwidth is nasa FR2. Okay? So if you want to calculate the guard band, meron yung guard band. So you have the channel bandwidth, minus 12, PRB, subcarrier spacing, minus subcarrier spacing divided by 2. So these are based all sa 3GPP standard na pinakita ko. Okay? Ayan. So you have the bandwidth. Okay? Okay ba tong bandwidth? Can I get a thumbs up? I'm continuously asking for thumbs up just to get you awake, no? Kasi this is a boring topic actually. This is a topic where the instructor, no? Sa mga is inaantok na yung mga tauhan nila, o yung mga estudyante nila. Of course, the frequency range. Yan. So, ano yung frequency range na ginagamit natin? So, it's either frequency range 1 or frequency range 2. But now, in the 3GPP latest standard, you will hear a frequency range 3. No? Yung golden frequency. Yan. So, hinihintay natin yan, no? Yung golden frequency na yan. Pero frequency range 1 and frequency range 2, yung pinakita ko sa inyo kanina, are the frequencies in the low band. Frequency range 1 is 410 to 7125, and then frequency range 2 is from 24.25 to 52.6 gigahertz. Yan. So ito yung frequency range. So makaka-apekto rin, no, kung ano yung frequency range mo para sa yung throughput, no. It depends sa frequency. Pagka tinanong ka, ano throughput? What is the throughput? The maximum throughput that you can achieve in a 5G system? Well, a typical RF engineer or RAN engineer or a 5G engineer will not answer you quickly. No, you will see that there's a lot of parameters involved before we say what is the maximum throughput that we can get. No, unless you give me parameters, I can calculate for you. Yeah. Okay. Okay. So next is modulation. Yeah. So even though you have a wide bandwidth, even though you use massive MIMO layers, even though you have multiple carriers, even though you use FDD, but if you have a low modulation, no, it will still affect the throughput of your 5G. So why is it like that? No? If you look at the modulation, so the modulation dictates the number of bits that you can transmit, no, in your connection. For example, if you use QPSK, you can only transmit 2 raised to 2 bits. No? You can only use 2 bits. Sorry. This is 4, this is 6, and this is 8. Okay? So this is the number of bits that you can transmit per symbol. Later on, I will show you what is the effect of this one. But the higher order modulation will give you a probable high throughput connectivity. Okay, because instead of 6 bit per symbol, you can transmit 8 bits. So you have a more number of bits being transmitted one time. Okay, so that is the number of bits, modulation. So it's very important for us to have. And of course, we have the numerology. So what is numerology, sir? Numerology is the subcarrier spacing. So it's not a very deep concept in 5G. So when you talk about numerology, it defines the frequency domain subcarrier spacing. Kung gaano kalapad lang yung subcarrier. Okay, so for example, we have 15 kilohertz, 30 kilohertz, 60, 120, 240 kilohertz. Okay. So the frequency domain bandwidth of a resource element, so this will be equal to the subcarrier spacing. Okay, example, increasing yung subcarrier spacing by a factor of 2, it will also increase the resource element bandwidth by the factor of 2. No? So that's basically it. Yun. So for example, ito yung a sine wave ng isang 15 kilohertz and then ito naman yung sine wave ng isang 30 kilohertz. No? So makita mo, mas maliit yung duration. No? Almost half ng duration ng isang 15 kilohertz. That's why dito sa mga high frequencies na yan, mabilis din yung latency. Okay? Kaya doon sa mga applications na requires higher latency or lower latency, we are using high frequencies because mabilis yung transition ng mga throughput mo or ng mga bits of information mo dahil sa behavior ng ating electromagnetic wave. Okay, so that is numerology. And then the numerology, if you look at more specific samples, ayan. So marami tayong numerology sa mga applications. Ayan, so meron tayong numerology 0, numerology 1, numerology 2, numerology 3. Pero ang ibig sabihin lang yan is the subcarrier spacing, 15, 30, 60, and then 120. And these are the expected use cases. eMBB, URLLC. Okay? Now, if you look at on a different perspective of numerology, ganitong itsura niyan, ano? So, if you have one slot, okay, so pagka tinignan mo siya dito on this side, you will see one carrier, one subcarrier, 15 kilohertz, okay? Pag tinignan mo sa gilid, and then, ito naman is yung time. So, this is the frequency, this is the time. Okay, so pasensya na kayo sa sulat ko, medyo pinaglihi ako sa manok. And so this is the frequency and then you have the time. No? So you have 14 symbols in 1 millisecond, okay? Or 0.5 millisecond or 1 millisecond. So this is where it happens. No? So lumiliit yung number of symbols and then dumadami yung number of symbols mo in one duration of time. If you're using a higher order of numerology. Okay? Ayan. Okay. Now, if you look at the Qualcomm illustration, so this care of Qualcomm, so this is how you will see the difference in numerology. So you have 15 kilohertz, 30 kilohertz, 60, and then 120. You will see here, sa perspective naman ito, yung front view natin is the carrier bandwidth. Okay? Dito sa is nakikita nyo is the time domain. Yung nakikita nyo nakaharap sa inyo. Yung nasa gilid is the carrier bandwidth. But in this perspective, you will see the carrier bandwidth sa front view. So that's a difference ng different numerologies. Okay, so medyo malapit na tayo. Next is the coding rate. Yeah, so coding rate is the number of bits that you transmit in your system for redundancy. So to avoid any error or to compensate for the error. Okay, so pag-usapan lang natin dyan yung mga coding rate, yung turbo code and then yung low density parity check, okay, and then polar code for 5G. So low density parity check for the downlink and turbo and the polar codes for the uplink. So essentially it's just a number of bits, redundancy bits na tinatransmit mo. So for example, nagtransmit ako ng 2 bits and then we say 50-50. So yung isa is for redundancy and then yung isa is the true information. Okay? Now, if I transmit 4 bits and then sinabi ko na 2 bits are for redundancy and then yung 2 bits is for information, meaning 2 bits lang talaga ang ginamit ko for data transmission. Yung information na kaya kong gamitin. Yung 2 is for protection. Okay, so ganun ang nangyari doon. So yung coding rate, importante yan. So kung ano yung maximum coding rate na pwede na ibigay. So the maximum is 924 something over 1024. So that is equivalent to 92.5% of the transmitted number of bits. Yun lang yung possible number of bits na pwedeng gamitin ng subscriber. And the remaining 7% is for redundancy and protection. Okay? So that is the coding rate. And of course, meron tayong scaling factor. So scaling factor depends on the number depends on the type of the frequency na ginamit natin. Because as I mentioned, each frequency has a different behavior pag pinabugo mo na yan sa network. The behavior of the 700 megahertz is different to the behavior ng millimeter wave. That's why we have a different scaling factor. And it depends on the location of the user. Nasaan ba yung user na yan? Okay, so probably the scaling factor ng 700 is okay, pero kung nasa cell edge ka naman, napakalayo mo na doon sa cell site, no? So the scaling factor, kahit na mataas ang scaling factor na gamitin natin sa calculation, if you are already on the cell edge, so it doesn't mean a thing already, no? Kasi masyado ka na malayo. Okay, so your calculation is not anymore accurate. Okay, and of course, yung overhead for control channels. Yan. May pag-usapan natin yan, no? So ito yung mga factors that are affecting the 5G NR throughput calculation. Okay, so you have the mode of 5G network, number of aggregated carriers, MIMO layers, bandwidth, frequency range, modulation, numerology, coding rate, scaling factor, and overhead for control channels. Wala pa dito yung traffic. Okay, because that is different consideration. For example, this testing is only good for one user equipment. Okay, so if we use one user equipment, okay yan. Paano kung maging 10 kami, sir? Paano kung maging 100 users kami? So it will now depend sa calculation, sa factors na yan. So kaya sinasabi ko, wala dito yung traffic involvement, yung number of users. Okay? Wala pa rin dito yung license na ina-activate mo sa network. Of course, you need to buy a license, right? For you to activate the specific functionality of your network. Probably your network has the capacity or the potential to have 1 gigabit per second. Pero yung binili yung license is not 1 gigabit per second. So you cannot achieve it. You will not unlock the potential of your hardware. Okay? So yun yung mga hindi kasama dito. Okay? And then yung path loss, yeah, if the path loss could be considered by scaling factor and the frequency range. But of course, the path loss, we will be dealing with the actual scenario na yan. Okay? Okay, clear ba to? Itong 5G NR calculation natin. Can I get thumbs up? Although for the first timer, that's why I'm asking everybody earlier who are the first timer, it's okay if this is too much for you. Eventually, kapag patuloy kayo sumasali sa Asia Open Academy, even though you don't have CPD points yet, okay, at least the knowledge that you will get, no, you can still use it. All right. So, now let's go back to the formula. Okay, so let's squeeze in yung formula. Where's that formula? Okay. So how do we use this formula, sir? So let's get back to the user throughput. Data rate in Mbps is equals to 10 to the negative 6 multiplied by the summation of the number of carriers multiplied by the number of supported modulation multiplied by the scaling factor multiplied by the maximum data coding rate, okay, and multiplied by the number of resource block multiplied by the number of carriers, subcarriers, and divided by the numerology and multiplied by the overhead. Okay, so let's digest it one by one. Isa-isahin natin. So sometimes equations can be intimidating, no, especially if people are talking with loud voices, they would like to intimidate you, no? And then using different such words. Even sometimes they forget to be polite, no? Even in these free webinars. But even though it's intimidating, we can still, no? We can still simplify what's being said, no? So, kapag sinabi natin yung 10 to the negative 6, it's 0.0001 lang. Yeah. 0.001 lang yan. It's just a number that's to convert it into mega Mbps or Mbps, no? Mega bits per second. Yeah. And then itong symbol na yan, so this is our favorite symbol, especially in the statistics. If you want to sum up or integration, no, sum of carriers. So we sum it up because if you use different carriers, just imagine this. For example, you have two carriers you use for 5G. Carrier 1, which is 2100, and then you have another carrier, for example, N78, 3.5 gigahertz. These two carriers have different modulation, and then these two carriers will have different propagation characteristics. These two carriers will have different bandwidth. These two carriers will have different coding rate. These two carriers will have different layers of MIMO. So you need to sum it up. Okay, that's why there is a sum of carriers here. And then this is the number of layers, the GNOB transmission streams to UE. Okay, so basically this is the number of MIMO. If it's 2x2 MIMO, 4x4 MIMO, or 8x8 MIMO. Next is the modulation order. So if you are using BPSK, QPSK, 16 QAM, 64 QAM, and 256 QAM, 2 raised to 8, 2 raised to 6, 2 raised to 4, 2 raised to 2, and 2 raised to 1. Scaling factor, it depends on the frequency if you're using FR1 and then if you're using FR2. So si 3GPP sa standards, naglagay sila ng baseline for scaling factor use. So 1, 0.8, 0.75, and 0.4. Okay? So ginawa na yun ni 3GPP so that we can have a guideline. Rmax is the maximum number of the coding rate, no? So in this case, 948 out of 1024 bits will be transmitted for data and the remaining 7% will be for redundancy. Okay, and protection. Yeah. So ito yung maximum coding rate na pwede nating makuha. So nakuha yan ni 3GPP based on empirical, of course, first is calculation, theoretical calculation, and then empirical data. So meaning from different tests na ginawa nila. Okay. Next is the resource block allocation. How many resource blocks do we have? Ito yun. These are the number of resource blocks. For example, you will use 100 megahertz. If you will use 30 or numerology 1, you will have 273 resource blocks. That's how it is being used in this kind of matrix. Okay. Yep. Okay. And the number of subcarriers, this is fixed. We always have 12 subcarriers. Okay. We always have 12 subcarriers in the standard of 3GPP. And you have this factor of how many symbols do we have, and the U or the mu is the numerology. What is the subcarrier spacing used in your calculation? Is it 15 kilohertz subcarrier spacing, 30 kilohertz, or 60 kilohertz? Okay, so meaning this one and this one are correlated. The scaling factor, what frequency are you using, what type of numerology is allowed in that frequency range, and how many resource blocks are assigned in that frequency range. Okay? So that is the numerology. And of course, we also have the overhead. Okay, so we have the overhead. What is the use of overhead? No? Because not all data that being transmitted is for redundancy or protection or for information. some of them are for synchronization and signaling, right? So for FR1 in the downlink, so you have 14% overhead. For FR2, you have 18% overhead. For FR1, you have 0.08% overhead and 10% overhead for the FR2. Okay? The data rate for include loss, that is included in the link budget, Emir, not on this calculation. That will be included in the link budget, not on this calculation. Okay? So ano yung overhead, sir? Why are we using overhead? So if you look at the different, we're going deeper, no? Pagdating sa 5G. Although we will have a different program or course tackling about these details, especially in the design, in the air interface, and the optimization of 5G. So we have the downlink physical channel and signaling. No? So you have the downlink and the uplink. So you have what we call the synchronization signal, broadcast signal, physical downlink control, physical downlink shared channel, okay, demodulation reference signal, phase tracking reference, and channel state information reference signal. So we'll not tackle this in this session because we are limited of time. In the uplink, it's the same thing. So what I want you to focus on is the PDSCH and the PUSCH. Okay, these two. PDSCH is the physical downlink shared channel. So this is where the carries downlink user data, and the PUSCH is for the uplink user data. So if you're downloading or watching YouTube or streaming some video in the Netflix, you are using PDSCH for your data transmission. And for if you are doing a Facebook Live, you are using video streaming, or you are transmitting video or uploading video, you are using PUSCH. Okay. Now, if you map it, no, if you map it in the frequency time domain distribution, so this is a typical example of a time frequency distribution. So this will be tackled in the air interface of 5G. Okay, especially if we go to the laboratory of Asia Open and Academy that will be built in the UP-EEE. Yeah, may meron pang konting plug. So we will discuss this further. Because if we discuss it further, we can see it, no? Ano yung nangyayari sa time frequency domain. But you will see here that PDSCH in the downlink are only limited. Not all resources are being used by PDSCH. Okay? Some of the resources are being used for signaling like PDCCH and synchronization like this primary synchronization and secondary synchronization. So in the under the synchronization signal block. Okay? Para magkaroon ka ng signal, syempre, kinakailangan synchronization. Right? So not everything is being used for PDSCH. Saan papasok, sir, dito yung modulation? Now, the PDSCH will be modulated, natatandaan nyo, 16 QAM, QPSK, 64 QAM, and 256 QAM. Now, if you will modulating this carrier or slot or putting the number of bits in the PDSCH, you will use, for example, you use 256 QAM. So meaning there are 8 bits in one symbol. So meaning you will put 8. I cannot write, no? So you will put 8, 8, 8, 8, 8, 8, 8, 8, 8, and then you sum it up. So number of ilang 8 bits ang pinadala mo. Okay? So you will have the idea na, yung pala, no? Pwede pala natin makalculate yan. So you just put the number of bits in those resource elements, and then if you have 2 by 2 MIMO, you multiply it by 2 because you have 2 different streams. Right? Now, if you have massive MIMO, mas maganda pa pala yun kasi you will get more good quality. And then if you have more quality, ibig sabihin, malalaman ng G-Node B na maganda yung quality mo, it will ask the UE and the G-Node B to use a higher order modulation like 256 QAM. Okay? So now you will have an idea, ganun pala yun, ano? So kaya pala, during the testing, you will see here na meron tayong signal to noise ratio, signal, okay? And then you will see here as well kung ilan yung modulation order na ginagamit at ano yung modulation na ginagamit niyo. Can you get this point? Now, the higher order modulation that you use will give you basically yung higher throughput. Okay? Yeah. So this is fundamentals, no? So if you're looking for a more detailed, it's not the avenue for this discussion, but I'll just giving you an idea how this being affected, no, by the calculation. Okay? Ayan. Now, going back to the formula. So this is our formula. Okay, so this channel transmission, and this is a sample calculator that I created. Okay, so this one, in this calculation, I just used, for example, 4x4 MIMO, and then I used 256 QAM, which is this one, 2 raised to 8. I use a scaling factor of 1 just to maximize it. Okay, I use the maximum Rmax. The numerology is 0. Okay, and then the carrier is 50 megahertz. The number of maximum resource block is 270. This one, and this one is coming from here. Okay, and I use overhead of 0.4 and total Mbps of 1 gigabit per second. So meaning using a 50 megahertz bandwidth, you can achieve a total of 1.1 gigabit per second. Theoretically. Okay. Ayun, theoretical lang pala yan, sir. So, but in the actual, we saw that if you use LTE and 5G, you can achieve the 1 gigabit per second. Imagine, no, itong bandwidth na to, this bandwidth is using around 60 megahertz. Okay? It's using around 60 megahertz. No? It's using 60 megahertz. This one. Okay? And the bandwidth of the LTE is 10 megahertz. So meaning, if you have this combination, most likely you will achieve the 1 gigabit per second. Provided that you will have MIMO, 4x4 MIMO, and higher order modulation, good signal level, and good quality of signal. And less subscriber. Okay. Okay. So, yeah. So that's the basic calculation, the basic concept of the calculation that we have. Okay, so this is a summary of the calculation using the 4 layers, the 256 QAM, scaling factor of 1, and the modulation. Now, if you want to do some exercises from your own, for your own, you can just do like this, no, what I did. So you can just get yung maximum download and then maximum upload. Okay. Yeah, so that's it, no? That's the how we calculate the eMBB calculation for 5G throughput calculation.